Here we are again in a secret basement underneath Funkin' Wagnall's department store, underneath the subway, hidden in a chasm so nobody can see any mistakes. Anyway, this is QBUS-110. We are continuing Section 10.3, which is basically business problems. We started this last time. This example is similar to number 4 on the in-class test. It's called the competitive market. As you can see, the revenue is equal to simply 50 times X. X is the number of units produced. The cost is given by this function. It's a competitive market because there's no way the demand can affect how we do with the price, and in the long run, the price sort of flattens out. The first question was to find the profit. We did this last time. So we took the revenue and we subtracted it from the cost, making sure we had the cost function bracketed. We then distributed the minus sign throughout all three terms. Getting this, subtracted 50x minus 30x, and we got minus 0.01x squared plus 20x, and that should be a minus. Then we took the first derivative. It asked for the marginal change. And the first derivative, I don't understand why I have a point. Yes, no, that's what I do. So the first derivative is 2 times minus 2 minus 0.01x. Subtract 1 from there using the power rule. Derivative of 20x is simply 20. Derivative of a constant is 0. This is the derivative. Minus 0.02x plus 20. Finding the critical points, we set the first derivative equal to 0. That's just what I did. I divided both sides by minus 0.02. And I got x equal 1,000 from my first critical point. And I believe that's where we left off last time. Now we want to find whether x equals 1,000 represents a max or a min point. So I'm going to use the first derivative sign test. I'm going to take the first derivative at 900. And then at 1100 on both sides of the critical point 1,000. And when I substitute into this 900, 1100, I get P prime 900 is plus 2 or greater than 0. To the left of 1,000, P prime 1100 is plus, I'm sorry, that's supposed to be minus 20. Minus, this is, I'm sorry, that's plus 20. But this comes out to be plus 2. This comes out to be minus 2. That's less than 0. So to the left or greater than 0. So that's going to be a positive slope going up, flattening out, and less than 0 going down. So 1,000 represents a maximum profit. Now we might want to find out what is our profit at maximum. So let's erase this. You do have this on your notes. Let's get this as clean as I can get it. So x equals 1,000 units is max. If I take the profit from the original function and find out what the profit will be at max. I did not ask this on the problem, but I go into my profit function, which is 0.01x squared plus 20x minus 1900. P 1,000, notice this is 1900. Okay. Is minus 0.01, 1,000 x squared plus 20 times 1,000 plus minus 1,900. And when you figure that out, I'm not going to do it out all the way. You'll get a profit of around $8,100. That's what you get from selling 1,000 units. The last part of this problem Actually, the problem is finished. So let's take example 2, and this is in a monopoly market. What does that mean? Well, I'm going to have a cost function. Flip over to page 10.3, and I will have a cost function, and that is going to be 800 plus 0.2x plus be very careful, there's 3 zeros here. I know on one of the tests there was 3 zeros in front of a 2, and you guys only put 2 zeros. All right, now they also give you this: P equals 2 minus 3 zeros for an X. Notice this is a price per unit. That is the number of units sold. So that's demand, that's price. Now notice demand depends on price. If I set my price, I can control my demand. This usually means that we only have one seller or one. So what do I have to do here? First, I have to find the revenue, and we know that revenue is price times price per unit times the number of units. So I'm going to take 2 minus 0.0004x and multiply it times x. A lot of people have emailed me on this and asked how to do the monopoly. Well, notice in a monopoly market, demand is controlled by price. We fix the price, we fix demand. So this is 2x minus 0.0004x squared. That's my revenue function, as you can see on your notes. Now you want to find your profit function. Profit equals revenue minus costs. So our profit function is going to equal to 2x minus 0.0004 x squared minus, remember the bracket, we're going to have to distribute 800 plus 0.2x plus 0.0001 x squared. All right, now this comes out to be 2x minus 0.0004 x squared. Just distribute the negative throughout all of them. So our profit function becomes, it's 2x minus 0.2, that's 1.8x. My 8s are terrible, so. Okay. Minus 0.004x squared minus 0.001 is going to be minus 0.0005 x squared, and the 800 sits alone. And I've now obtained my profit function. Okay, if you look at it, that's exactly what's in the notes. Now the next step is to find the critical points that maximize profit, just like the other problem, but instead in a monopoly market. So let's erase the top here. Okay, I'll erase it up to here, where the profit function is. If I don't get all this stuff out. So now I want to find the marginal change in profit. So I take the derivative. I got to stand up for this. So P prime X is going to equal to, well, you have 1.8x minus 0.005x. So it's going to be 1.8 2 times that is going to be minus 0.0010x minus 0. So now to find our critical points, we set p prime x equal to 0. So 1.8 minus 0.0010x equals 0. 1.8 equals 0.001x. I don't have to put the 0. Divide by 0.001, of course. And x becomes 1,800 units. Okay, now that's our critical point. Now, is that on a maximum since we want to maximize profit? Let me write this a little bit better. It doesn't look like units. Okay. In this case, to find max min, I'm going to use a different technique. I'm going to take the second derivative. That's the second technique we have for determining max min. So the second derivative is the derivative of the first. So the first derivative, p prime x equals 1.8 minus 0.0001 x. Let's take the second derivative. This is going to be 0. This is going to be minus 0.001. Sorry, let me make this a little bit better. So this is less than 0 no matter what my x value is. That tells me that I do have a monopoly market. Less than 0 for the second derivative. This is the second derivative. This is the derivative of the first derivative with respect to the same independent variable. This is 0. So this tells me that I'm at a maximum point. Why? Because when it's less than 0, we are concave down. Okay? So we had a maximum point. So we know that x equals, x equals 1,800 units is at a point of maximum profit. I don't ask you to calculate the profit at that, so I won't bother going into it. And that pretty much represents the end of that problem. And before we go on, I just want to say something about Section 10.4. Section 10.4, I'm going to just to erase up here. You have these all in your notes. Okay, we're going to omit Section 10.4 for now. So for your homework, you're going to do Section 10.2, which you should have done before, 10.3, and 10.5. You should have that homework. I gave it to you before. I'm going to give you, since I want the take-home test in Monday, I'm going to give you until Friday. And that will be what? April what? Monday's the 30th? Is that the 4th? Friday, April 4th. Send that to me by email attachment. We know that Canvas doesn't work right now, and I'm not going to bother with it. So that's your homework, and that covers everything that I covered. Section 10.2 we covered before. It was on the take-home test. And it's basically diminishing returns and concave up and concave down. So that completes...
We gotta cut it off. We gotta stop.
Oh, okay.